and I am going to get right into it. Yesterday I deviated. I didn't work on my CAD library at all, which is I think totally fine. Nice break, little idea that I kind of wanted to try out a little bit, so I think totally a reasonable thing to just kind of tangent with a little bit, so I'm pretty okay with that. Just checking that the connection's actually going up here. There we go. Looks like we're good. Alright, so today though I'm gonna get right back into working on this CAD library work. So in particular I'm keen on trying to make sensible svgpath functionality here. Let's see here. If I go to path, there's a few different sort of types of things you can draw with the path function or path element. Different domain specific language things kind of built right in there. And I wanted to try make or keep going with producing functions that kind of wrap this behavior. So I have an arc that mostly works. There's some conditions stuff that I have skipped for the time being, and I've got a half implementation of Bezier curves, which I'm gonna keep working on Bezier and see if I can come up with a sensible sort of interface to all of that. So that's kind of the general idea for the day. So I've got here, I've got a REPL which I'm gonna just load up. Where am I at here? svg.cljc, and switch to that namespace, and I should be good. If I evaluate this, looks like we're in the namespace. And here, if I now go, well, let's get right into the code. That's path, Bezier, these here, I'm in the process. These are not obviously real useful names. Hey Marispooner, how are you? Again, always messing up my pronunciation, but sorry about that. Hope you're doing well. Nice, glad to hear it. I'm doing okay. Yeah, just getting into the swing of working on this CAD library, and feeling pretty good today. Feeling pretty good. Anything new going on your end? Let's see here. Oh, I have to pass it a list of points. Oops. There we go. Okay. Oh boy. Just trying to refresh my own brain on where I left off with this stuff. It's been a couple days, so it always takes a minute to just remember the train of thought I had going with things before. There's also the other thing. I have this. Oh right, I still have to actually open this file here. So if I go here, that should be good. let me see now. Nope, that's the wrong. Here I've got the test thing. Right, let me see what happens now if I just comment that out. Just make sure that the what's going on here? Oh, this. I need to do this. There we go. Perfect. Okay, so we have the hot reloading working just fine here. That's all that is. This is just sort of a test bed I've got built for doing this. For visually checking the functions I'm working on. That's really all that is. And then this is just a REPL for these functions over here. Okay, so oh man. Okay, I gotta focus today. We're gonna attempt to focus, I guess. Okay, so the functions I'm in the middle of working on are right. So this weird cubic and weird cubic 2, they're different. Oh, let's see. Maybe I should. It'd be kind of cool to. Actually, here, let me clean this up just a little bit here. Okay, so arc tests. Let's entirely get rid of this here. This stays and this stays, and that should, let me just, okay. Okay, that's arc tests, so that lets me now just delete these here. The only reason I'm keeping them is because I still have to work on the arcs. I just don't want to do it right now. So I just clean up that section of code a little bit. Makes it a little more readable in my opinion. What I actually think is a brief sort of tangent here. This color element function I want to make so that it works like recursively. So transforms here. If I take this interface thing here as a starting point, then I can do that in the style section as well. Okay, so we've got paste that. So we have the interface, color. So all I should have to do in this case is go and change any call in this setup here. Instead of scale element, we do color element. And here we do color element, color, and then we recur on that, and that should, I think, it should work. So we'll find out, actually. We'll run that. Oops. If I take this snippet here, copy that into the REPL here, and just do this. Okay, that works. Oh, that's, well, of course that'll work. Color element is still gonna work fine. Okay, so this did not work. Nth not supported on persistent array map. Why would that be the case? Is color an existing function already? No, that's probably not it. Okay. Oh yes, of course. So color element takes smap, kprops, and content. So this has to be smap. I think smap's a bad, let's call it style instead. Styles, no, just styles, fine. Okay, so here, obviously what I have to do is adjust this let call because I don't need it to be sx and stuff like that. So let's see here. Style can be, let's just assume it still exists. Right, so we go like that. So then we just call color element with style element, and then this style like that, and then here style. Okay, let's give that a shot. Oh, of course this, since I changed it as well, style like that, and this. Okay, now let's attempt to use color. Okay, that seems to work. So, okay, that's a good sign anyway. So let's refresh this page and just change this here to color. Should work. It doesn't. Okay. Huh. There we go. Okay, so now we have this color function theoretically working fine. Which should get us, it should just make things just a little bit easier to write out. Right, so what I'm doing in this case now, so I should be able to, oh, you know what, let me just leave that in just to be safe. Wait. No. I'm second guessing myself here. Sorry about that. Okay, that still works. Perfect. Right, so what I want to do though is just kind of make this a little more readable. It's not perfect. Ish. Okay, here's what I wanted to try and do. Perfect, kinda. It's hard to see, but these two functions build the cubic Bezier curve differently. Does this work? Yeah. Let's do this. also want to do this. I'm gonna make this function work a little bit differently. I want to do color, k props, and content like this. And then here, let color be a map where I do fill color like that. And then the only difference here is I do k merge props style, no, k merge props color like that. Content. Okay, so that's color element now, and style element is some generic sort of thing. So that should let me make this color thing simpler. Right, so this first argument to color should be just a valid CSS thing. This should fail here, but I should be able to refresh it. Oh. Right, that's one issue. Oh, wait a minute. That I don't want the fill. I want the stroke color, right? Is that oh, it's just stroke. Like that. Save. Refresh that. Okay, so we're almost there. Stroke color fill none. See, this is where color does actually get, like, I need to be more particular about how I build this. Right now it's fine for what I want, but it's not good enough because I want to be able to independently control the stroke color and the fill color. So I need a better approach. Right now I'm just hard coding fill none into the color, so it's only coloring the line, right, which isn't what I want. I also have an issue that has to be style element, and path here, these weird ones, right? I need to change this to style element instead. And here, style element. I think that'll work. Oop. Hey, big old problem, eh? Let's see here. I messed something up. That's okay though. I can go like this. Okay, we're in a state that kind of works. Let's see, that broke it. Now let's build. Okay. What's wrong now? Cubic Bezier string, S Bezier string, declare translate. I don't need to do that anymore. Style element should exist. Well, let's check out arc again. Let me just double check here. I do have yeah, circle by points. Things should work. I am surprised why these aren't working. I thought it would be fixed, but okay, I'll try to figure it out. Style element should not be undeclared. Let's see here. Okay, so I have style element here, and then I have path, let's see here, source svg, right, so I have in the function cubic Bezier, right, around line 600, here, style element is a function I'm calling, but oh, it's a typo problem. Okay. That's silly. Ugh. There we go. Okay. Transforms, style element. Those typos always get me. It's silly on my part, I'll say that. Okay, we're in a working scenario. No. Okay, refresh again. There we go. There we go. Now we've got something to work with. Right, so color blue. Let me get rid of that color and we'll go split this here. Right, so we've got the SVG here. Translate each of those, and we've got one extra. There we go. So save that. There should be no, yeah. perfect. Well, I mean, it looks weird, but that's the intent for the time being. Color, let's do this one is pink here, and then this one, color blue. If we save that, we should get 2 different line colors. Ooh, that pink isn't legible yet, so we'll just do red. It's a little bit ugly. The colors are a little bit intense, but they're useful for visualizations. Okay, so this here, weird cubic 2. You know what? Let me swap these around. It doesn't matter, but right. So weird cubic is red. We have we have non-smooth points here. Which you can see better here, right? So this is just a bunch of, let's inspect it for a moment. The path is actually, see that? They're independent paths entirely, like that. I didn't bother to merge them or anything like that, which actually is kind of not the smartest, but I digress for a moment. This one, the blue one. Hey, why'd you do that? Oh, right. There. This one, I think, should be just one path. So if I look at that, I should see only a single G tag. Yep. Wait, what's in here? Oh, all the circles and stuff. That's fine. And just one path that is a continuous curve here. So that's nice. There's one problem where the input points list is not a one-to-one match for the actual control points that build that curve, because there's implicit control points. So there is, it's not drawn here, but there is at this point there's an additional point here, and then that is a control point. This is a point on the curve, and there's another control point here. That's a control point. This is on the curve, and then there's a, in this instance, what is it? I forget, but there's another mirrored control point, kind of should be here, I guess. Does that make sense? Does that make any sense? Anyway, I don't know if that's necessarily the smartest approach, right? So that's what I'm thinking about at the moment. I also do need to, well, now this might be a good time for a bit of REPL work here. If I do closed path, actually let's def A as a list of points for a minute that we can work with. Let's do 0, 0 is the starting point. Let's do 25, 50. $25, $50 is pretty high. 50, 100. No, I want to do. Let's. I'm lazy. I don't want to think it over, so I'll just do this for a minute. Oh, scale 1. Let's make this kind of diamond thing here, and we'll use this as a starting point of coordinates because it's easy. Oh, where am I at here? Should have a copy to clipboard button, that'd be nice. Let's do 0, 0, 20, 75, 100, 75, 50, 25. Okay, that is just a list of points. Right, so if I do closed path of using A, I get this path value. Now if I do translate this path, if I translate it 100, 100, it does correctly move the points there. Now, if instead I do, what do I have here? Path Bezier. Cubic Bezier. Let's do that. Cubic Bezier of A. No? Really? Oh. Apply. There. So here, let me extract things a little bit here. Let's do I just need this, so it's second from first of that, I think, gets me the path. Oops. Nope. Well, let's first of apply cubic Bezier A G. Last. There we go. That's actually what I need. Right, so this path string here is not the same as the closed path string. They're different. So if I translate 100, 100 of this thing, I think it will work, but it'll produce an invalid, like it moves. This is correct, the starting point here. But now, instead of doing a C call, it does a line to this point here, another line to this point here, and then another line to this point here, and then closes it. So it just mangles away. It basically undoes the curve effect, right? Like it gets rid of the fact that it's a Bezier curve there. So I need to fix that to allow my transforms to work properly. So what I think I need to do, well, what do I need to do? Well, let me zip on up here to, let's have a look at the, excuse me, the translate of the path here. What I have happening is, oh boy, for path and paths, here, closed path string. This closed path actually, sorry, I need to look even further up here. Paths is path to points. So if I take, let's def B as this, and then I do path is the get from P in position, we've got 1D. Def P as get from B. I'm writing things out a little weird here. So P should be, oh, I did it wrong. Get from B, oh, get in. There we go. Okay, so this is a cubic Bezier string. So if I do this function here, path to this function here is what I'm looking at, path to points of the string, the path string, right? I nicely do get the point values, but the obvious issue there is that it ends up ignoring the type of path element that it is. So that's not that's definitely not good enough yet. So in order to fix that, I need to think about how I want to handle it. And before I do, I'm gonna be right back. I have to check something. Okay, so I really kind of do need, since I'm adding functions to the path that build up actual strings, it's like I basically need a parser compiler for the path string information, right? Because I need to know, I need this function, this what I just tested, path to points, right? I need it to be able to know to tag the type of path that it is, which is an interesting conundrum. Well, let's build a little helper function at the start anyway. This here probably should be pulled out into its own section, but I'll just build it here for the time being. If I do define path type, and then we go s is the path string that I'm gonna get. What I want to do is build a function that'll tell me basically what kind of string it is. So types of paths would be what's correct here? So let me have I can have a look actually at here. Okay, so we can have right, so path type is going to be line, arc, quadratic, or cubic, basically, right? So move to is whatever, line to will be what we look for to determine if it's a line-based thing. H and V we don't use because we just use line 2. Curve 2, this is technically a cubic, so it can contain, it must contain C, it might contain S. Quadratic must contain Q, might contain T. And then an arc must contain A. So that's actually not too hard. Types of paths, line, arc, quadratic, cubic. So using that, well, let's just start with cond, and we have s/contains. Do I not have the string library in here? I do have Clojure.string. Replace exists. Okay, let's see what functions. Includes, I think, is what I'm looking for here. Okay, so the string Adam, does it include D? True. There we go. Okay, so cond includes. Well, let me reorder this here. String includes S. If it includes L, then you return key line s/includes. I wonder if there's like a better way for this, but well, we'll just go with it. Okay, C. Oops. Okay. Let's see then. If I run path type over the test path, it does give me cubic. So now if I run path type over, oh, what did I, is A, B, yeah, so if I run path type over get in 1, d of closed path using the points A. This should give me line if I were to do it right. Closed path A, yeah. Get in. Oh, I did this in the wrong order, that's all. 1D. Yep. And now if I do path type of that, should give me L line. Perfect. Okay, that's good. Let me do now, if I have an arc, 0, 0, 23, 50. This should produce a valid arc. Okay, let me now do, one little problem here. The arc string function, I don't want it to put new lines in there, actually. So let's go to arc string, interpose that. Here, I actually don't, let's interpose a space. Let's see if that changes the final result there. Yep, it does. Okay, so let's just copy this, and if I do path type and paste that, it's an arc. Okay, perfect. That's nice. So that arc and Bezier are works in progress, but that's a start. If I call weird cubic for a minute, okay. Oh, I actually don't want that one. I want weird cubic 2, which, by the way, let's change this to work in progress cubic and get rid of that one. Save that. Okay. Ignoring this G tag with all of that stuff we've got and that polyline, this is one path string. Path type. It should just give me cubic because it contains the C cubic there. Now this function works assuming the path string is not a compound path string, right? So what I'm gunning for basically is I want every, so line based path can be some polyline thing, polygon even, and it's gonna have all its points listed out on one single line. Then you can have a compound path that has Bezier curves in that, but that'll be separated by a new line and then the string for the Bezier curve. So you can just combine paths basically all with that single approach. Now the one thing that I have no consideration for yet is closed or open. All that is if the very last character is a capital Z, then that indicates that the entire path is closed. So pardon me. So I could make where am I at here? Yeah, path type closed, and then all I do here is last S I don't know if this will work. Oh, it does. Okay, so all I have to do there is equals the Z character. Wonder if I do char Z, is that maybe clearer? No, that's not a thing. I don't know how this works. Oh, that's a little weird, but okay, so closed, right? So if I do well, let's just go back here. So path type closed, false. This one, arc, if I ask is it closed, it should say false because it does not have the Z at the end there. Now this one, here, that's a line. Now if I do closed, true. Okay, good. So that's just going to be useful at some point for right? Basically, if I translate, scale, or rotate a path value, I have to basically pull apart the path string, get all of its point values back, like get all of its data basically back, run the transform on that data, and then correctly put it back as whatever type of thing it was, right? So this here closed path string works just fine if you give it a list of points, but I need to be able to if it's a cubic, right, you need to call the right string function to build up the string again. Okay, so let's just check, is it true that in every case well, let me okay, line S is that this one is an arc, so let's def arc string as this, and then this one is def cubic S is that. Okay, so we'll start with those testing things. Let's look at cubic S. Okay, so there's the move to, which is an XY value, which is good. C has it has XY, 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 3 points, can be useful. S has XY, XY, S has XY, XY, S has XY, XY. Okay, so that seems silly, maybe, but it nicely I was gonna say I could do if I do path to points of cubic S, right? I get everything split out as the correct number and order of things here, right? So then I could do well, let's make a function. Let's just make a function here that does define cubic path string points. Let let's make a little here. This move to string given point x y. Yeah, then it's just this whole thing. String m x y and that should be it. Move to string right, which if I give it a point 0 0, of course I am always doing it wrong there, right? So move to string, if I destructure it like that, then that there, that's what I was looking for. Which can be used to recreate that, which is fine. That's good. Let's change the name of this to M string, like that. Then this, I don't need in this function, because I just map, or I just run mstr on first of points, then apply string to interpose map to the rest of those, and then you put a z at the end of that for closed path. So that's good. Right, so in a similar vein, C string is just going to take x1, y1. Wait a second, let me check this here. There's 0.1, 0.2, 0.3. Yeah. Okay, so it's actually, which I already did make this function elsewhere. I'm gonna have to reorganize this code, the path code, but for now I don't need to. So C string is just, actually maybe I do need to. actually realize, let's take this here as an example, and let's make a more useful set of functions here. Right, so this C-string function, I'm going to just start it like this. Okay, so, oops, that's not what I needed. In org mode, the double square brackets like that mean it's a link. So sometimes if you destructure stuff, you end up accidentally making invalid links. And if you click it, it tries to open something that doesn't exist. So minor pain in the tuchus, but life does go on. Right, so let me try to make a generic defin dash string, which takes leader and points. Okay, so then all you do is this, apply string to interpose space between the list that is concat leader points. Let's see if that actually will work. That's probably a bad function name. So let's try string leader is m and the points is just 0, 0. Almost, not quite. Okay, we're getting close, but that's not totally correct. Of course, because you have to split out this is still going to be wrong. Right? Yeah, okay. Let's actually think this over for a second. If I just print points dash string of m, okay, it's a list of a point. That's good. Now if I imagine it's not m but c, and it's 0, 0, 10, 20, 0, 29. Okay. Right, so, okay. Okay, so, right, I need to, can I map cat this? Apply map cat to that? Flatten, maybe. Yeah, actually, so that's actually what I need. So let's try this now. I think this could work. So if I apply string to interpose a space between the if I conj leader onto the list that is flatten points, does that give me what I need? Let's find out. No, not quite. And the reason for that, class exception, string cannot be cast to persistent collection. Okay, I messed something up, but okay, that's no problem. Is this gonna work? Yeah, okay. Right, so I was trying to not force everything into a vector, but I suppose I need to if I'm going to interpose and then apply string to that. Maybe I'm missing something, but point is, this should work as a generic approach. So if I do L, oops, L between 0, 0 and 10, 2, L 0, 0, 10, 2. Is that the correct syntax? Let's do line string. L. Ooh, L is wrong. Oh, okay. That's okay though. That's not a. This was just a test, and it was incorrect. I wonder if there's a way to do interpose but skip the first one. Pure not, and it doesn't matter. It was just a. Yeah, we'll leave it for now. That's okay. Okay, so this M string thing, I'm gonna delete that actually, and here it's just gonna be dash string M, and that should still work. And now here, instead of doing C string, well, I don't need it at all. Let's just get rid of it. Okay. So we have now this cubic path string function. I'm going to do let, oh, even line 2 here I don't need. Ooh, let's try this. So instead of map line 2, I actually can do map partial dash string L onto rest of those points. Now I do need to check that this will work. So if I do path to points of line string, I'm given this set of points, which is fine. Now if I do closed path string over this, it does appear to give the correct value. M00, L2575, L175, L5025 with Z at the end. Okay, so that is great. Perfect. So that just means all I have to do is string together the different elements of this. So it's, for me, or here, I could even destructure it actually. let's actually see if that's correct first of all. Let's do M, and then the rest are points. Is that gonna work? Let's see. Okay, so close path string. Let's run it again. Wrong number of arguments. Right, so it would have to be M. Oh, now I have to do apply, right? Will that work? Nope. Yeah, so it would have to be, I have to do it like this. Close path string, M points. Well, let's change this, of course, to M. Did I mess something up here? Okay, let's try that now. Almost. Not quite. Oh, here, and this doesn't have to be rest points anymore, it can just be points. Okay, that looks like it'll work now. Okay, is that the right? Is that right? I forget now. I don't think it is. It's missing the last point. Should it actually be M? Oh, there we go again. There we go. M and points. Okay, so that actually lets me do this a little differently here. So the cubic path string happens to be built up from an M, and then the next one, let's have a look here, is for sure, shoot, this is maybe this isn't a perfect idea. Well, let's try it. Let's see if it ends up making sense. So if I do cubic string, right? So the first point goes to the M, the next 3 go to C, and then the remainder go to 1, 2, 3, and then if there are any left, it's every 2 per an S group. That's a little annoying. Okay, so M, C1, C2, C1, C2, P2. Actually, this could be P1, C1, C2, P2, and remaining points. Yeah, that'll work fine. So then this, we gotta do P1 there. Oh shoot, I'm editing the wrong thing. This is incorrect. This just has to stay M. That's my bad. So I need to be over here doing this. So P1, C1, C2, P2. Those are the first 4 points are earmarked for special stuff. So we do string M for P1. Yeah, let's go with this for now. String C with, and you call that with C1, C2, P2. And then you separate that with a space. And then the last thing you do is apply string to interpose space between the map partial dash string with S. You run that over how can you do it? This is actually different. This here is map some function over the partition 2 of points. Okay, and this function here is, if I do, well, let's try build it out. Partial. No, I would have to run it like this. I would have to do, no, maybe let's see if this will make sense. Apply partial dash string S, apply that function to 1, 2. So you map that over partition 2 of some list of things, which is just a list of points, right? Yeah. So let's just copy this for a minute. It doesn't have to be like the real set of points. I just want to put one too many of these there. Doesn't work. Okay. If I do partition, well, let's just look at the partition 2 of that whole thing. Right, so first of that is 2 points. And now if I do apply partial string S, apply that to first, to this whole thing. Yeah, oh, I just, this is just wrong here. I don't need to, if I do apply, I don't need to run, yeah, so if I apply, this should work. Sweet, it does. Okay, so with that, then I should be able to take, right, so let's just do apply partial, oh boy, partial S over partition 2 of that. Okay, let's see if this works. So we've got cubic string, right? Let's clear this. Cubic string is that whole thing. If I do path to points of cubic S, I have a list of points, And then if I do cubic path string of these points, right, it doesn't work. Okay, so that's fine. And why is that? I don't actually know. Oh. There we go. Okay, let's see if that does match the input string. Well, let's say equal cubic s. It's working. That's fantastic. So that does then mean the only other thing to now work on is the arc, at least for now. So let's look at arc string, okay? It's actually easier, right? Because it just is gonna have, ooh. So this is where things might get a little messy. So if I do an arc string, right? So the first thing is a point and it's m, so that's normal. And then these aren't points, but are they, if they're even numbers, I can fake it. I don't think that's necessarily the smart idea. Also, a brief tangent. Two, 4, 6, 7. 2, 4, 6, 7. It's odd numbers, so if I just do this, path to points of arc s, it's not correct because it drops the last, it drops this last point or value here, which has an important, like I can't ignore that because why can't I ignore it? What does it mean again? Oh, that's right. It's the y value of the end point. So it's really important. So, I mean, I could pad it and actually, so I realized, so the arc string is actually going to have to be quite different because it has different logic built into it. The arc string is actually going to be hard, kinda. So the two things that are actually points with an arc string is this one here, the m part of it, and then the end 29, 0 is the end point of the arc. Everything else is not point data. This and this, those are the radius, the rx and the ry. These are flags. This is a rotation, if I recall. Oh, no, sorry, I was off by one. This one is the rotation. These are flags, and then this is the point. Yeah, so the whole syntax of the A part is completely different than, it's not just points. So I do have to it has to be different. Shoot, that's gonna be tedious to say the least. Let's see. I realize I'm basically making a def multi scenario here. I should probably refactor this soon. Put it into its own path thing here. What I mean by this is, right, I have this conditional. I don't actually need a conditional. What I could do is dispatch, I could make a def multi path string, right, that dispatches based on, oh, well, actually, yeah. So I could have, yeah, maybe. Actually, let's see if I can do that. Yes, so we will go def multi path string. Yeah. And now, because I am not a genius, I'm gonna go here, def multi, and have a look at how I did this. Right, so I'm just wait, let me think. I can do something like this. Okay, so my bad. Here, path, def multi path string. This is not what I needed to take, but it's going to be that takes a ooh, what's the right approach here? I actually need two def multis, I think, because so for everything except the arc, this isn't too hard, right? Transforms, so rotates, translates, and scales work nice and simply on lists of points. For line, cubic, and quadratic path things, I can easily and reliably turn a string, a path string of those types, into lists of points. do the transforms on the points, and then put it back into the appropriate path string. What's different is the arc setup, but I have this situation where I'm doing, like, I need both. I need a back and forth. So the first thing, I actually need, here, let's kind of sketch it out a little bit here. I do need, so for the translates and stuff to work, it's starting with an existing path thing. It's got a D value, which is the string already. So I need def multi path string to path string to path. Let's call it that. Oof. So it's going to take S, that's the def multi, and it's going to dispatch with, basically it's going to return dispatch on path type of S. I think that'll work. Am I doing this wrong? Let me double check here. I'm pretty sure I messed, or something's a little off. Oh, what? I don't need this. That's a mistake. Okay, so transforms, translate element here, def multi, translate element. Oh, and it takes the function immediately. So this is wrong here. So it's just going to take function of S, and then it's going to return the path type of S, right? So then that's going to dispatch, it's going to be any of these four things. So then def method path string to path of S if we know that it's a line, then all we have to do is run the function path to points Well, let's see if this will even actually work as I want it to. This should also, by the way, be here. Yeah, so, right, so let's take this line one as an example. We'll see if this actually works. What we should end up with is, let's do concatenate line with path to string of S. Nope, path, string to path, right? Nope, path to points. These names need rework because they're going to confuse me like crazy, but let's go ahead and do this and see if I can get that to work at least. So if I do path string to path of line string it does kind of work. Okay, so that's helpful, and whoop, be right back. Okay, back into it. Okay, so we have the situation. It is correctly dispatching, which is nice. And I can actually do this. I think that'll actually make a difference, right? Yep. Okay. So all this is doing is tagging the list of points with I suppose I could actually do it as I actually could change this idea up a little bit and do let's make it a map, I guess. Let's try that. Type line and then points. Yeah, that's not a bad idea because it can make our other functions a little easier. So let's do now line. Now we've got cubic given s, type is cubic, and then the points can be points just fine actually. Line, cubic, quadratic can even be the same. Actually, I have an even better, I have a different approach here that'll work just fine as well. Type can just be path type, points is path points, and all I do is that's default. So the only other one I need to do, okay, so this declares how you dispatch. The default is this. You run path type over s, and you get the type and you get the points. That'll work for line, cubic, and quadratic. Then the only other one you need is arc, which takes s, type is arc, points is path to points, s is not correct. So this is, the arc one is where points should be different, I think. But since my arc function takes p1, p2, p3, I can make points. This will be a little more involved, but it shouldn't be a real problem. Let's do you can have a closed flag there. Right, so if in the case of an arc, you are going to get a string. It's going to look something like this. If you run path to points on it, it's going to be incorrect by, it's going to be off by 1. So how can you fix that? Well, actually, so let's make a special function just for arc path to points. Okay, so this arc path does take a string, and it's going to run a few different things, and it's going to give me p1, p2, p3 as a list. So then here you can just run arc path to points to get s, and then that should technically be all you need, because when you return, or when you go back to produce the path string from it, there will be another def multi that brings things back around. This is a little confusing to me, but basically I need another def multi that does path back to path string, and then I need to update my path transforms to use that function instead, and then we should be okay. I think that makes sense. Does that make sense? It might make sense. Boy, oh boy. I've confused myself a bit, but confusion's okay. We can get through it, and we can have a better working system for this anyway, so I'm okay with that. Right, so let's work on this here, arc path. Let's start with that, and that maybe is good enough for us. So given a string, let's copy this and adjust it as needed. So let's do the thread as macro. So we thread the string as s. So here what you do is replace in s, z, remove z at the end of path, split string at spaces, which is fine. Splits on alpha characters. Filter not blanks, so you just clear blank things in the in your list of characters. Or it won't be a list of characters, it's just it gets rid of empty things basically. Then you map read string onto S, and here partition, actually the only difference here is going to be partition all. I think that actually will work. So if I do arc path to points of arc string, I do indeed get a useful list of points, and then all I need to do there, so that gets me a list, right? And then from there I do first of this is P1, last, oh, that's not quite right. So okay, let me change my plan here. Let me change up my plan. Let's try, let's change this up here. So let's do s replace. So we replace any alpha characters like this. I think this will work. Replace in some string oh, I'm doing this wrong. Okay, so replace in arc string any alpha characters with nothing. Okay, that works. And then if I do s split this string on space characters. Oop, geez, I'm getting a little crazy with my key presses. Okay, that gets me a list of things, a list of numbers. Then if I filter not equal I could do not, I could do complement s blank. I think that'll work. Right, so if I filter this list of things, yeah, and then I do partition 2 of that. Wait, that's not right. I have to, because that's an odd number, right? Odd? Oh. Okay, so let's just count it. Oop. I was trying to get clever. Come on. What have I done? There. Yeah, so it's an odd number, so I can't just partition. So what I need to do instead is, okay, so at this point I need to kind of work with things. So this is how I'm going to do this. I'm going to do let s be the thread first macro of s, and I thread it in such a way that I do s/replace all of the alpha characters in the string with nothing. And then I split that string on what was it, space, like that, and then I have to run that thing through a filter. Complement s slash blank. So that's s. Then we have p1 is just going to be into vector take 2 s. Yeah. I've realized a major flaw in my arc assumptions here, and that is that I actually have a P2, a method of calculating P2 from all of these, but I don't. There's an infinite number of P2 possibilities. This is going to be a real problem, actually, but let's press forward. I'm wondering if my arc implementation shouldn't be a 3-point interface. It should be something like start point, center, and sweep. I don't know yet. If I do it by start point, end point, sweep, I could reverse calculate everything. Wait, could I? Potentially. This is a mess. I don't like this, actually. It's a little bit frustrating. So what I'm going to have to do instead, actually, is pull specific data, because technically I still can use, I should still be able to use wait, maybe I can calculate a third point, if not the third point. This is actually complicated. Like, have to, you kind of like, you basically, if you want to hold on to, since I'm just like evaluating the transforms back into SVG element nodes, I have to be able to take those nodes, reverse engineer. I have to be able to calculate the original data from it. So they have to be clean transforms with no data loss. And that works quite fine everywhere for every shape except for arcs because of a few challenges. If I just make the arc implementation just where the user has to do the start point, the end point, and the radius. See, the problem with that is the user might calculate incorrectly the end point. You don't want to have the user calculating anything. You just want them giving points that, okay, hey, computer, calculate this. I know this arc has to go from here to here and has to be through these points. So no matter what I do, I have to come up with these sort of convoluted approaches to calculating different parts of the arc on my own and doing my best effort to recalculate translations. This is needless to say, this is a bit of a pain is what I'm getting at. But what I can theoretically do is, well, let's go ahead with this. So I can pull P1, I can pull P3, and I can pull the radius. We'll start there, and we'll figure everything else out as we go. Okay, so you can take last two from some list if it's short, right? Yeah. Right, so P3 is take last two from S. I'm thinking in my head about changing this. Yes, I'm going to do this. I'm going to delete this function entirely, make this like that, and then go from there. Oh, I should copy these two though. What's this again? Okay, we're in a reasonable spot. Okay. Points, we're gonna get there. Let's do it this way. P1 we'll go like this. Move that into here. P2 is this, and it's not P2, it's actually P3. Okay, so we've got a close the let there. Okay, we're in a reasonable spot now. What I can do is destructure. Oh, maybe maybe I could have done this. So S is, let's destructure it actually right away. So the first two things of S are, yeah, so okay, so we have a list here of 7 items. So let's just destructure it. It's going to look a little messy, but I'm going to be okay with that. So we're going to do P1X, P1Y. It's the first two. RX, RY. X degree is that one. The sweep is that's the large, and that's the sweep, like that. And then this is P3X, P3Y. So if I do that, close off that's the let statement. So P1 is actually really easy. It's just like this, P1X, P1Y. Likewise, P3 is P3X, P3Y. Really straightforward now. Okay, so we've got, that looks correct so far, but let's go ahead and just add these other bits of data. So if we do RX, RX, RY, RY, X degree, a little redundant, but safe and readable for the time being. And that should be good. Okay, so let's see now if this makes any sense. Let's see if I've made mistakes. I mean, I probably have, but we'll start with that. So if I do path string to path of arc S, okay, there's an error. Messed something up. Oh, right, of course. This one's gonna be it's not perfect. Also, don't need to do that, I think. Let's see if that fixes it. Nope, still wrong. Okay, so let's try that now. Okay, we're good. So closed false, RX is that. P3, yep. P1, yep. Okay, so it looks correct. The maps are not sorted by default, and once you have more than 8 keys, the order is no longer guaranteed, so you should never rely on order of the map anyway. But they're keys, right? So it shouldn't matter anyway, right? Like you can still run a get over those, no problem. Okay, so this path string to path function works for arcs, works for lines. Oh, wait, what? Shoot, I have to fix that. how do I oh, Clojure unbind def method. Remove def method. No, I always forget this. Well, let me try this. Okay, so that's saving. That was weird. It shouldn't take that long. Okay, let me do mx sysman restart, and let's see if this works. Okay. Load file, source, stylo, svg.cljc. Perfect. And then all I need to do is switch into that namespace. And we should now. Oh, of course, I don't have that defined anymore because I restarted my session. That was silly of me, but let me do. Well, okay, let's run closed path on. Let me just do this. Okay. Right, now let's test out path string to path of line S, and it should be in a map form. Yeah. Excellent. That is good. Now, path helpers. Now we come up with an approach for the opposite thing. Basically, I will get rid of these in a minute, but whoops. We begin by doing a new def multi up here, or down here, I mean. So def multi, instead of path string to path, it's path to path string. And these names, I don't know how to name them better right now because they're going to be really confusing. But I'm going to just, that'll be an off stream, sit and think and reword things and stuff. Yeah. Okay. Right, so for this approach, instead of S, we're going to call it P for path. And it's just going to be, you're going to dispatch on the type key type like that. And that should work. So then you actually just have, basically I'm going to just kind of recreate that logic there. So def method path to path string given the key line, all you have to do is build out the same function, m and points. Nope, actually this is going to be different. There's a way to destructure a map, but I don't want to search it right now. So we'll do it as a let. Oh no, I should search this. Clojure, destructure map in function arguments. Let's have a look here. How do you do it with a map? This as keyword, I'm sure I should use more often. That'll actually probably clean things up in my code a little bit. Okay. Associative destructuring is similar to sequential, but applied instead to key value structures, including maps, records, vectors, etc. The associative bindings are concerned with concisely extracting values of the map by key. Okay, so without destructuring, yeah, let, name, location, description. That's exactly what I was going to do. So instead, the destructuring form is now a map rather than a vector. Okay. Yep. Okay, I think this is what I'm looking for basically. So let me see here. If I do okay, so let oh no, I don't want to do a let right away. I need to do this, right? Keys right, so it's gonna have the type I don't need, points. Let's start with that. And then points, we just destructure in a let for simplicity. So it's going to be let m and points from points. So then here we do, here we're at we're in the situation that is just the rest of this. So I can actually just copy and paste this into here. And this will actually just be when closed. Okay, let's see if that works. Okay. Have to do this, and then have to do this. Something's wrong there. Oh, points. Okay, so map literal must contain an even number of forms. Oh, I did that incorrectly. It has to be like this. Let's see if that works now. Okay, so path to path string of line. So if I now have a look at this, if I run path to path string of this, do I get the correct line? I have 3, 3, 14, 67, 8, 85, 73, 58, 18. Okay, that is quite promising. I'm pretty happy with that. Right, so then for basically for the next one, so we've got line, we've got it won't be line, it will be cubic. We can copy this like that. And see if that works. Something's wrong. Oh, right here, I didn't assign points to that. So now, if I do, if I run this function, weird cubic, hey, really? Why doesn't that exist yet? I thought that. Oh, right, I renamed it whip, which I should really change to that there too then. Okay, all I want from this is this line. Yeah. This is not a real thing anymore. Let's get rid of this entirely. Okay, so def cubic string. Perfect. So now let's run path string to path of, is that right? Path, yes, of cubic s. And now we run path to path string of this, and we should get the same thing out. Let's do, is this equal to cubic s? It is. All right, perfect. I'll be back soon. Where was I? Okay, so we have cubic and lines working in both directions, as far as I can tell. And now let's attempt to build path-to-path string for an arc. Now this is going to be the hard one. I think. So let's do keys. Right, so let's make a quick arc string here. So if I do arc P3 is going to be 100, 0, and P2 is just going to be 50, 50. That should get us a nice clean arc. So let's def arc string as this thing, which is just right here, nice and easy. Paste. Okay, so if I run path string to path for arc string, okay, we get this key, or we get this map. So the keys of this that matter are kind of all of them, right? So actually, except for type, all of them but type matter technically. So let's do P1, P3, Rx, Ry. X degree, large, sweep, 1, 2, 3, 4, 5, 6, 7 things, and then closed. That should be all of those, I think. Okay, so given all of that, the result will just be what will it be? Zip on down to the path part here, arc. Here, this part. So we know that the first part of this is let's string together the dash string function of m, and we take p1 and we slap a space at the end there. That's nice and easy. Then the next thing is actually going to be, let's paste that. So this is a bad function name. I'm gonna have to change it. I'll change it after. Probably I want to install I'll finally figure out how to install an Emacs thing that does change definition names or whatever it's called, where it changes the calls to the function when you change the name of the defin. Anyway. My brain's slowing down, I can feel it. Okay, so this dash string function takes flatten points. I can cheese it a little bit with this. I should be able to. If I make if I do A is the leader part there, and the points are P1, P1, Rx, Ry, X degrees, and large, and sweep, and then this one is P3. I think this could work. We'll see soon. That's actually it. Okay, let's see if it works. Okay, so we have path string to path of arc string, right? So now we just run path to path string of this, and we should get the equivalent out. It looks good. Let's run equals if, false. Okay, so we've messed something up. And what is it? Oh, yes, of course. I don't need P1 here. I just need it to be starting with Rx, Ry. There it is. Okay, now we're good. Okay, so we have a working situation. We've got path to path string and path string to path. So the only considerations left So this works. This will be easy and straightforward for Bezier curves, for closed and open polyline paths, just straight line paths. So line, cubic, and quadratics I don't have yet, but that's actually going to be pretty straightforward as well. It is going to be a pain for arcs. Arcs are always going to give me some trouble. because of this, where so these values, they don't matter except for the fact that if you do a scale inverse to flip things, to mirror things, these do matter. And if you do a rotate, this actually, I think X degree is the only one that will never matter. Oh, I actually have to do this when closed on all of these. I do wonder if that'll work. What'll that look like? Perfect. So if I do arcs closed, let's try a closed one. I'm just gonna copy, oh, come on. Copy that, add a Z there. Okay, now if I run, does it keep the Z? Ooh, it doesn't. Typos, typos, typos. Closed is false. It should not be false. Let's have a look here. Closed. Let's run that. Closed. True. Transformed S. There. That should work now. Okay, there we go. It's got the Z there. But now I'm curious if this will accidentally have a nil at the end. Good. Sweet. That's good. Okay, so that works nicely for the closed situation. The arcs are still going to be a huge pain to work with after all. I actually thought arcs would be relatively straightforward when I started working on them, but they're turning out to be the most complicated ones, basically because of how you're supposed to specify them in the SVG. I don't like the semantics of it. It's weird semantics in my mind. Anyway, that's just how it goes. It's going to be a bigger problem than I thought, but I just have to think about it really and implement something good. So that's fine. It's just part of the game. So if I what should I do next? Right, so, let me try. Yeah, it works with the line, that's good. If I do def open line S as this, get rid of that Z, and then run this on open line. Perfect. It does not add the Z on there. And now let's do one final test here. Cubic S is open. If I do def closed cubic string, this whole bad boy with a Z there. Okay, and then I run closed cubic. Hey, it did not work, so that means I missed something here in path to path string line cubic. Oh, here, I didn't put it in. When closed Z okay, that should now work. Yep. Good, and let's just double check. Perfect. Okay, so that's all nice. So now the only one we have to do is, oh, I haven't put quadratic back in yet. Well, let's go ahead and work on that. If I def, or cubic, I mean, no, quadratic is right. Def quad string as m let me I need to find quadratic. Let's use this, that's fine. Right, that, if we def quad S as this. Oh, that's wrong. There we go. Okay. Path type of quad S should be Q, quadratic, perfect. Path to string path should work. Path string to path, I mean, of quad S should give me quadratic closed false points 1080, 95, 10, 180, 80, perfect. And then the only thing I need to do there is create. Oh, these, by the way, can actually, oh no, I need to keep them just for, this one can be gone, but this one I want to have a big old delete this one when ready to switch to using, to switch over to path to path string slash path slash path string to path functions. There, that's fairly obvious, yeah. Line, let's go here, def. This cubic one is going to be very similar to the quadratic one, so let's go there. Keys, closed points. When closed Z there, that's good. This is Q. But instead of this, we actually have just P1, C, P2. That's all that is. And then endpoints will just be with a T. Oh, that's wrong. This has to be Q. And then here, this will be, instead of S, this will be T. But Q here is actually just going to be C and P2. And then that should be T, and that should be closed, and everything else should actually work just fine. So let's try that. So we have path string to path of quad S gives us this map. And now if we do path to path string of that, okay, so do we have, are they equal? They're not equal, so what did I miss? Oh, they are except for this space at the end here. And the reason for that would be why? Oh, here. I don't need this if I have this. Oh, that's a lie. Wait, what? What happened? Oh, that's very weird. Interpose space. Yeesh. Okay, let's save that. Something went weird with my clipboard there. Or my, sorry, not my clipboard, my undo history. I think it's not what I expect it to be. Okay. So now this path thing is gonna be, this is a big kinda right, so if I do translate, if I have a look at translate element path, right, what I have right now is, well, okay, actually let me do closed path very wrong. That is very wrong. And that's because I'm giving it the wrong data. Let's do closed path of path string to path of line S. There we go. No. Now we've got, okay. I have to work on this. Points. Okay. That's perfect. So that's a closed path, a valid closed path. Okay. So let's translate 100, 100, P. That works. Good. So what I want to do is create a situation where this translate element path function will still work even though I'm using the new functions that I created. So what that means is I have to do paths is not going to be path to points. It has to be let me go one step easier here. Nope, that's not. Let's split. That's what I meant. And split again. Okay, so this one here only works on closed paths. Whip replacement below. Okay, so here we go. I don't want to, let's not mess with a good thing, well, a working implementation yet. Let's work on another one below it here. Whip. And we'll start with path strings is just going to be s/split lines of d props. So far we're in exactly the normal spot here. So this old one would be, so paths. Now what I can do is map path string to path over path strings, and that gets me a list of the maps which will look like if I do path string to path of line string, it's this shape. So then new paths is for path and paths, instead of running this function, right, over for path and paths, you're going to have this map. And you can do map right, so this function, right, so it won't be closed path string, it'll be, well, first of all, let me do, let x points, oh, gotta use the right, let here, x points be this function, map plus xy map that function over the points key from path. Okay, so that's x points, transformed points. And then instead of running closed path string over that, what you're going to do is run path to yes, you're going to apply path to path string. You're going to run that over the map that has assoc points. You assoc into the map path into the points key x points. So you run that over that, close that for, and this should work. Let's find out. Okay, so we've got path p, and we have translate 100 100 over p. Looks like it worked. That's exciting. So now let's go ahead and do create a work in progress cubic from cubic string. right, cubic string, nope. Eesh. Okay, so we need to do, let's get path string to path of cubic string, and from there we do points of that, gets us the list of points, and then that is what we run with. If we do whip cubic of this, we kind of get what we want, which is going to be, if I do last from that, do I get the path? I forget. Yeah, so def C as this whole business. So C is a path that is a cubic Bezier curve. So what I'm checking now is I should theoretically be able to successfully translate this thing looks like it worked. Yes. Okay. So what that means is I have in fact correctly, I think, it looks like this is working, where I can translate element paths just fine. The only thing that won't work is, well, and so we can actually kind of sort of check our logic a little bit. If I do scale to 2 of this, we get a big mess up. The path doesn't match at all because it's still using the old approach. Okay, so that's looking pretty good for scale. So it looks as if we have a good translate function working, which I'm really happy about. Okay, now we go to, well, let me actually do a little copy paste as a reference. We just change that for rotate and translate, or pardon me, rotate and scale, and then we'll be covered for straight line paths, Bezier paths, quadratics, but not arcs. And by default, with how I've set it up, is any compound path that's got straight lines and Bezier curves all together should theoretically work just fine with the new translate approach I have. The only thing that doesn't work is arcs, because arcs are going to be kind of a pain in the butt. Okay, rotate element. Let's have a look. Let's try to get. Let's try to finish rotate element and scale element in the next couple of minutes. I might be able to do that. We'll find out though. So rotate 45 degrees path P. That does look different. Yes, good. So if I rotate 45 degrees C, it's all wrong. Good. So let's start with rotate, split here, split here. Let's paste our example in there. Okay. So okay. So we have to calculate center a bit differently. We can start by doing path strings, that's fine. So path strings is split lines of D props. Paths, I'm going to map, okay, if I do this, now here center has to be calculated differently. I cannot simply apply concatenate to paths. So what I was doing here before was just saying, so all the paths are just going to be points. But what I can do is apply concatenate to map points of paths, and that should be fine. So what all this is doing is take the key points from all the path lists and concatenate all of those together, and then use all of those points to find the bounding box center of the whole thing. And now new paths is going to be for path and paths, instead of closed path string of this thing. Okay, so rotate point about center by degrees from the center. So if you map that function over path, I'm letting myself get confused here. Okay, let's go up here and we do let transformed points be map this function Let me do myself a little favor here. Transform function is this. Map xf over points of path, like that. Yeah, and then this is the result. So instead of closed path string, now what you do is run path to path string of svgpath points x points. Then new props should basically be, that should work. Let's see if I've messed it up or not. Okay, so let's go rotate 45p. Okay, the function works. And now let's do C. Did it maintain? Yeah, it looks like it still has that there. Okay, so it looks as if rotate is still going to work. Save that. Okay. And finally, we go to scale, where, let me copy. Let's go for that. If I don't want to roll things back, but if I need to, I can roll back from my last git. But that's going to be kind of a pain. So I'm just going to hope this is okay. So we'll use this as a template again for the scale function. So scale path. So split, paste that there. Oops, that's the wrong button. Well, that's fine. Okay, we go back up to translate element path, copy, paste. Okay, so here we are. Path strings. Paths is this new thing. Right? And here, once again, we do apply concat to map of points paths. So that's the center. Let transformed points be let's do xf is this partial thing here, and then transformed points is that map xf over points from path. Oop, did I goof? I did, I goofed. So that's the let, and then then we copy this bit here. We don't need any of that anymore. Paste that. Oops. Okay, so that's new paths. Then we should be good. Let's see if I broke it. So let's scale by 2 the element path. Looks good. And now let's scale by 2 the element cubic. Okay. It looks as if we've got a working situation. And we get rid of this. Okay. Let's go and have a look at, let's just double check that I didn't leave the translate element. Good. Okay. Let's give that a big old save. And let's go ahead for a moment here and throw that into Git. Okay, so that was, in my opinion, a really quite good. I'm quite proud of that work today. So I built out a sort of system for destructuring the path string into either a line, a curve, a line, a cubic, or a quadratic, and an arc, and adjusted the transforms to work with lines, cubics, and quadratics without issues. And then the only outstanding thing is the arc one, which has some more complicated semantic juggling because of how I want to interface with the arc and how it's actually written out in SVG. So the arc one is still kind of a pain. But what I have to do next is just probably spend some time deleting old notes and reordering the code structure again, streamlining a few things there. So that's really kind of boring but probably important mechanical sort of work. But I'm really happy with that sort of updated approach to handling paths, because if I think about it, probably I'm going to be doing a ton of path manipulation stuff when it comes to projecting 3D views onto the 2D SVG canvas. So probably I'm going to rely very heavily on path elements. So that is probably good that I'm working on that. But that's enough chit chat. I had a really good, productive day. Not a ton of chatting, which is totally cool. If anyone is watching live, thank you for tuning in. I really appreciate that. If anyone's watching on YouTube or on the VODs on my Twitch channel at some other time, thank you for that as well. Please follow or like, subscribe, all that good channel growth stuff. If you feel like helping me out, those sorts of things are relatively easy, but quite beneficial on my end. So please go ahead and do it. Of course, no pressure, but it's very helpful. And I'm going to leave it at that. I will be back on Thursday and on Friday. So I hope everyone has a good one. I hope you are doing well wherever you're at. And if you're not, that you have peace and confidence to carry on. Anyway, that's enough for me. I'm going to get going. Have a good one.